Good morning, dear students. My name is Ferhan Mazher, and the subject today we are studying is Cambridge O Levels Physics. The code of the subject is 5054. Today we have set our hearts to solve a paper 2 of this subject, and for that purpose we have selected the 5054 to October November 2025. The time allowed for this paper is 1 hour and 45 minutes, and the total marks for this paper are 80, and the G value in this paper we will take as 9.8. The question number 1 is showing up on your screen. A car travels along a straight horizontal road initially at a constant speed. The speed time graph in the figure 1.1 shows the motion of the car from t equals to 0. At the time t equals to 5.7 seconds, the driver sees an obstruction on the road. The driver applies the brakes a short time later and the car begins to slow down. Using the figure 1.1, determine the speed of the car at the time t equals to 0. Okay, so when the time is 0, what is the speed? Or we can say, we can look at here. When the time is 0, so what's the speed? It is basically, this speed is how much? This is their question. Okay, this is basically 29 meters per second. Okay, so the answer will be 29 meters per second. From the graph, I am giving you this answer. So the answer is 29 meters per second. So you can see the answer is right. That's it, right. Okay. So question number 1 is A part and its second portion. The distance traveled by the car between the driver seeing the obstruction at t equals to 5.7 seconds and the car begins to slow down. You know, this is a speed time graph. We have a speed time graph here. And the car started slowing down here at this point. So we have to, and he saw that thing at 5.7. The 5.7 is, let me increase the size so I can show you. 5.7 will be here. So it's 40. We want to show you this 1, 2, 3, and here somewhere. 5.7 will be here somewhere, okay? And this time here is 6.4. This is 6.4 seconds. And this is 5.7 seconds, okay? So the area under the speed time graph is equal to the distance traveled. So this area will be like a rectangle, okay? So I can easily find out the area, the distance traveled. The distance traveled by the car from 5.7 seconds. So the time we are taking is from 5.7 seconds to 6.4 seconds. The area, the distance is equal to the area under the speed time graph. That is equal to the area under speed time graph, okay? Speed time graph. That shape of that graph is like it's like a, a rectangle. So its area is equal to length into the width. The length is 6.4 into 5.7. So the length will be something like 6.4 minus 5%, that's 0.7 seconds. And the speed is 29. That is the length, the width of that rectangle. So 0.7 into 29, that's 20.3 meter per second. So from where the 29 is coming, let me show you. Okay, that is, so we are basically talking about this. Here it is 29. So the shape of the graph is something like this. Okay, here we have 5.7, here we have 6.4, and this is 29. So the area, so it's a rectangular shape. So the area under the speed time graph is in the shape of a rectangle, and you can find its area by length multiplied width. So the length is 0.7 and 29 is the width. So just multiply them, you get the distance traveled. So my answer is 20.3. So they have rounded it off to 20. Okay. So when you can write it like 20, so our answer is right, sir. So this is how this is done. Okay. So we are done with the question number 1 is A part, second portion. Now we are on the third portion. He says the distance traveled by the car between the T0 and T11.2. Okay. It's a 3 marks question. You know the distance is equals to the, because the speed time graph is given here, because so the distance traveled is equals to the area under speed time graph. Okay, that area will be in the shape of trapezium. Okay, so this side is 29, and here this is 6.4. Here it is 0. This is 11.2. So this side, so this is 6.4 and this side is 11.2. So this will be the height of that trapezium. So you can apply the formula for the area of the trapezium, and that is 1 by 2 into the, so the distance is equal to the area under the speed time graph, and you know that the formula for that trapezium, because that graph in the shape of a trapezium, is 1 by 2 into the height into sum of the parallel sides. So this is the formula. So 1 by 2 into 29 into 6.4 plus 11.2, and that 1 by 2 into 29 is 17.6, and so you got 255.2. So my answer is 255. So let's check. They have rounded off to two significant figures, so you can write it like 260 meters. Okay. So let's go back and move to the next one. Question number 1, and it's B part. The speed of the car affects both the thinking distance and the braking distance. State one factor. One factor that affects only the braking distance of the car. Explain how a change in this factor increases the braking distance. You see, the speed of the car affects both the thinking distance and the braking distance. So another factor which will only affect the braking distance is the braking system. It can be the condition of the tires. I can say the condition of the tires. The condition of the tires. If the tires are worn, then the friction between the road and the tire will become less, and the braking distance will increase. The car will cover a longer distance before coming to rest. Okay, because the friction between the road and the tire will decrease. Let me show you. I have also written this answer, and here is the answer written by me. The factor is the condition of the tires. If the tires are worn out, they have less friction with the road, so the braking distance increases. This is my answer, sir. And you can also look at the marking scheme. He says any one factor from the mass of the loaded car, condition, wear on tires, state of the road, brakes, reference to friction. Anyone matching explanation? Heavy load, worn tires, slippery smooth road, reference to reduced friction, reduced deceleration, or increase in the time taken to stop. So because of the the less friction, so it will take a longer distance to stop. If tires are worn out, they have less friction with the road, so the braking distance increases because now that friction is producing less deceleration is being produced. Acceleration is being produced. Okay, that's why it's covering a larger distance. Okay, so let's move to the next part, and we are done with the question number one. So here we go. The question number two is coming up on your screen. Let me reduce the size. Okay, so here we have the question number two on your screen. A spherical container is used to carry measuring instruments to the bottom of a lake. The figure 2.1 shows the container held at rest just below the water surface of the lake. The container is released and falls through the water to the bottom of the lake. The container reaches terminal velocity before it hits the bottom of the lake. Explain in terms of the forces on the container, the motion of the container through the water until it reaches the terminal velocity. And how many marks do we have? We have 3 marks for this. Okay, so explain in the terms of the forces on the container. You see, when the container is going downward, okay, so its weight is acting downward and the drag of the water will be acting upward. Okay, so at the start, the drag will be less and the weight will be more. Okay, so what will happen? There will be a resultant force in the downward direction, so the ball will accelerate because there is a resultant force. Okay, because there is a resultant force present, so that's why what will happen? The body will accelerate downward. As the speed will increase, okay, as the speed increases, what happens? That the drag increases. Okay, so the drag will be increasing. So eventually, at some point, what will happen? The drag, the drag will become the friction force of the water. The drag, because that your speed is increasing, the drag is increasing. At some point, what will happen? Eventually, what will happen? The drag will become equals to the weight. When the drag will become equals to the weight, what will happen? The resultant force will become zero, the acceleration will become zero, and the speed will become constant because the forces are balanced now. And that is called the terminal velocity. You see, terminal velocity is gained when the forces acting on that body, they are balanced. In this case, the drag will become equal to the weight. Drag and weight, they are acting in the opposite direction. So the drag is acting out in the upward direction, the weight is acting in the downward direction. So when they become equal to each other, the resultant force becomes zero and the acceleration becomes zero and the body moves with a constant speed. We call that speed terminal velocity. I hope you understand. Let me show you. I have also written its answers. So let's see. And then we will check it from the marking scheme as well. So here comes here is the answer which I have tried to write. And you can always write a better answer, you see. And you have also multiple sources from where you can write a better answer. So it's just a suggestion that the answer should be written like this. The weight of the container is downward. As the speed of the container increases, the drag of water which here is acting upward, increases. Result Resultant force decreases. Eventually, speed of container becomes so high because it's speeding up, so high that the drag force becomes equal to weight. Resultant force becomes zero. Container's acceleration becomes zero, and it means it moves with terminal velocity, which is a constant velocity. Okay, so the forces are balanced. That's why it's moving with the. So as the speed of the container increased, the drag force increased, and that's why that drag force become equals to the weight. Initially, its weight causes acceleration or speeds up or gains kinetic energy, friction drag, resistive force, viscous force increases as the speed increases or resultant force decreases. Acceleration decreases to zero or friction drag, resistance, resistive force, viscous force is eventually equals to the weight or the force is balanced or resultant force is zero. So this is the marking scheme for this 3 point mark 3 marks question. This is my answer. This is the marking scheme, and this is my explanation. And you can always write a better answer. Write your answer yourself. It's just an idea that what you should write. Okay. Question number 2 is B part. He says the container falls through a vertical distance of 32 meter. So that is the H. Before it hits the bottom of the lake, the container and the instruments have a total mass of the 74 kg. Calculate the energy transfer from the gravitational potential energy store of the container. You know the gravitational and the potential energy that is equals to mgh. The m is given here. The m is given here. The h is given here. The g value is 9.8 Newton per kg per Newton, or we could say Newton per kg. The G is equal to W by M. Yes, Newton per kg. Okay. So this is my solution. The gravitational potential and energy loss is equal to mgh. M is 74 kg. The G value is 9.8, and the vertical height to which or the the distance traveled is 32 meter. So you can say 23206.4. So you can round it up to 2.3 export 4 joules. So let's check. Let's check the marking scheme. And in the marking scheme, it says 2.3 export 4 joules. Our answer is right. So this is my solution of the B part. Okay, now B second part, he says state the principle of the conservation of the energy. You see, according to the principle of conservation of energy, it talks about an isolated system, and the total energy of that system always remains constant. The energy can neither be created nor destroyed. Energy only changes from one form of the energy into another form of the energy. So let me show you the things which I have written. In an isolated system, energy can neither be created nor destroyed, and energy only changes from one form to another form. Total energy of the system always remains constant. Let me show us a 2 marks question. Energy can neither be created nor destroyed. Energy can be transferred from one energy store to another. Okay, so then we have the question number 2B, its third part. He says, work is done to transfer energy from the gravitational potential energy store as the container falls at terminal velocity. Describe in the terms of the work done how the energy is transferred from the gravitational potential energy store to other energy store in the water. Okay. So they are talking about the terminal velocity. Terminal velocity is a constant velocity. Remember, this is a very important concept. You see, whenever the body is moving with a constant speed or terminal velocity, you can say uh, the energy transfers, okay, but you never say that the energy is converting into the kinetic energy when the body is moving at a constant speed. You always say that the energy is converting into the thermal energy, into the internal energy. Do not say that the kinetic energy is increasing. So in this case, what will happen? The gravitational potential energy will be converting into the thermal energy, or you can say the internal energy of the water. because that energy is being that heat is being dissipated into the water, so the water's temperature is supposed to rise. So gravitational potential energy will convert into the thermal or the heat energy. So internal energy of the water increases. Okay, let me read from here. Energy transferred by doing work against friction, drag, resistive force, resistive force to the internal energy store. Okay, the temperature will, whenever the internal energy increases, most probably the temperature will rise. Okay, so that was the question number two. And now we are done with the question number two, and now we are going to the next question. This is the question number three coming up on your screen. He says, figure 3.1 shows a firefighter directing a jet of water at a wall. In 1 second, a volume of 7.5 expo minus 3 meter cube of the water hits the wall horizontally. At a speed of 24, the speed is given. This is the initial speed of the water, and this much is the volume of the water. The density of the water is 1000 kg per meter cube. So this is the story they are telling us. Their first question is calculate the mass of the water that hits the wall in 1 second. Okay, you know the density is equals to mass divided by volume, and the mass is equal to density multiply volume. You know the density of the water is given here, and the volume of the water in 1 second is also given here. Just put those values here, and you will be able to calculate the mass of that water which hits here. So let me show you. I have also done this part. Let me show you my solution. And here we have. So you can see the A part, the mass is equals to the density multiply volume, 1000 multiply 7.5 into 10 raised to power minus 3. This volume was given in the question, and you can see it here. And you just multiply them on the calculator, you will get 7.5 kg. 7.5 kg is the answer, sir. Question number 3, and it's A part. First question. So here we have the solution. Let me show you my solution. Okay, and let's go to the next part. He says the horizontal momentum of the water that hits the wall in 1 second. Momentum, you know, the momentum is represented with the small p, and that is the product of the mass and the velocity. So the product of the mass and the velocity, the mass we know, and we just calculated in the first portion, and we know the velocity 24 meter per second. So you can calculate the very easily. You can calculate the momentum. So the momentum will be equal to 7.5 multiplied 24, because the velocity of the water when it hit the wall was 24 meter per second. You just multiply 7.5 with the 24, you will get 180 kg meter per second. 180 kg meter per second is the right answer, sir. Okay, this is my solution. Let's go to the next part. Okay, so here we have, he says that the horizontal momentum of the water decreases to 0. Okay, so the initial momentum of the water is 180 kg meter per second. The final momentum of the water is 0 kg meter per second. He says that none of the water bounces back from the wall. Explain and why the momentum is equal in size to the horizontal force. Okay, you know the force is equal to the change in the momentum divided by time. So the force is equal to the rate of the change of the momentum. In this case, the rate of the change of the momentum will be 0 minus 180 divided by the final momentum minus the initial momentum, and the time taken is also 1 second. So it will be equal to 180 Newton. So the force will be equal to 180 Newton. So you see, the force, the resultant force or the force is equal to the change in the momentum. Change in the momentum is also 180 kg meter per second, and the resultant force is also equal to 180 because the force is equal to the change in the momentum divided by 5, and that change took place only 1 second. So I hope you understand this calculation. They have not asked you to write that calculation. I'm just writing this calculation to make you understand what happened there. The horizontal, explain why the momentum collected is equals to the size. Okay. Initial momentum is equal to 180 kg meter per second. Final momentum is 0 kg meter per second. So in 1 second, change in the momentum is equal to 180 kg meter per second. The rate of the change of momentum is equal to the force. So you can see that force is equal to the change in the momentum, rate of change of momentum, and also equals to the initial momentum. This is my answer. You can phrase it in better words. But let me show you the marking scheme. Marking scheme says that because this question is of 2 marks and this is our answer, and the marking scheme says the force needed to change the momentum, or answer to this is change in the momentum. Force equal to change the momentum by time taken, or the momentum of the water that hits the wall in 1 second is the rate of the change of the momentum. This is the marking scheme, and this is the answer written by me, and this is the explanation words which we have used there. And I hope you can understand it and you can write a better answer. So let's go to the next part. So we are on the question number 3, and we are done with the B part, and now we are on the C part. Okay. So in the C part, he says, explain in terms of the Newton's third law why there is a horizontal force exerted on the wall by the water. Uh, you see, this is that wall, and when the water will hit, this is the jet of the water. The water, the wall, the wall will apply a force on water, and the water will apply a force on the wall. Okay, so this is Newton's third law. Because the wall has applied, because the wall made the momentum to change, so the wall applied the force on the water will apply force on the wall. This both these forces are called action and reaction. Both these are forces, action and reaction. They both are equal in the magnitude, and but opposite in the direction. But they have the opposite direction. Okay, so these are the main points. The wall applied the force on the water, and the water will apply force on the wall. Both these forces will be equal in magnitude, opposite in direction, plus they act on different bodies. Okay, we call them action and reaction. So let me show you my answer. This is my just explanation what the question means. And here we have wall exerted force on the water. Water will also exert an equal and opposite force on the wall. Force on the water is action, and the force on the wall is reaction, and both the forces are equal in magnitude, opposite in direction. They act on different bodies. This is very important. Let me show you the marking scheme, sir. Newton's third law quoted, or when object A exerts a force on the object B, then the object B exerts an equal and opposite force on the object A, or the forces only occur in the pair. The wall exerts a force on the water. So I hope you can write a good answer as well. This is our answer, my answer. Okay, sir. So now we are on the question number 3, and it's D part. He says the pump that forces the water to flow through the hose is adjusted, and the speed of the water leaving the hose doubles. Okay. Now, if the initial speed was V, now the speed is 2V. If the initial mass was M, now because the speed has doubled, so the mass will also become double. Okay, and the speed of the water leaving the hose doubles. Explain why the force exerted by the water on the wall increases by factor. You know the momentum here is the product of the mv. This is the first momentum. But now the momentum, the number two momentum, will be equal to the product of the velocity and the mass. The mass is 2m, the velocity is 2v. Now the momentum will become 4mv, which means 4 times the initial momentum. Now the momentum experienced there has become 4 times. So that's why the force and we know we have just calculated in some previous part that the force is equals to the initial momentum here. In this particular case, this happens. The force is actually equal to the rate of the change of the momentum, and that was numerically equals to the initial momentum because the final momentum of this water was 0. So if the momentum has become 4 times the initial momentum, so the force will also become 4 times. It's a 1 mark question, but a little bit heavy question. Mass of the water doubles, velocity of the water doubles, the momentum of the water becomes 4 times, so the rate of change of momentum also becomes 4 times. So here I have tried to write the explanation. So you know that we have in this previous parts we have shown that the resultant force is basically equals to the change in the momentum divided by time. So the change in the momentum this time has is also become 4 times because your momentum has become 4 times. Okay. So the force will also become 4 times. Okay. Mass flowing through the pipe hitting the wall in 1 second doubles, and the momentum water hitting the wall in 1 second increases by a factor of the 4. A little tricky question. Easy, but it's very tricky. So this 1 mark is difficult to get. Okay. So now we are on the next question. The next question coming up on your screen is the question number 4. He says that a large test tube contains a thermometer and some solid wax at a temperature of 21 degrees centigrade. So that wax is basically solid. Okay, so this is very important. And the initial temperature of that wax is 21 degrees centigrade. At the time t equals to 0, the test tube is partially immersed in a beaker of the boiling water, and the temperature of the wax is recorded for the next 600 seconds. Obviously, the temperature of that wax will start increasing. You see, and that solid wax has initial temperature 21, and as the time passes, the temperature of that wax increases, and after this after 400 seconds the temperature of the wax has become constant, and they have recorded up to 600 seconds the temperature of the wax. So figure 4.1 shows the variation of the temperature of the wax with the time t. So let's see what they say. Explain how the figure 4.1 shows that the melting point, the melting temperature of the wax is 63. Okay, it's a 1 mark question. You see this here, the wax was solid. Okay, so you are providing heat and the temperature of the wax is increasing. But here you see the temperature has become constant. You are providing heat, but the temperature has become constant. This happens only when there is a state change taking place. So there is a state change because the wax was solid. So here the solid is converting into the liquid. So we can say that the melting is taking place. So because why the temperature? Because the temperature has become constant and the wax was solid. So that means the state is changing, and obviously it is changing into the liquid state. So it's a 1 mark question. Let me show you my answer, sir. Okay. So here comes the answer which I wrote. Temperature has become constant at 63 degrees centigrade, although heating is still being done, which means the solid wax is changing state to the liquid wax. So the melting is basically taking place. This is the answer which I wrote. And now you can see the question number 4 on your screen. Its marking scheme is showing up. So he says the temperature remains constant, the line is horizontal, gradient of the line becomes 0. It's a 1 mark question. This is what I have written here. Okay. Then they say question number 4 and its B part, he says, here we have. As the temperature of the wax increases, the energy in the internal energy store increases. The mass of the wax in the test tube is this much, 0.040 kg, and its temperature at the time T0, the initial temperature is 21. The specific heat capacity of the wax is 2100 joule per kg per degree centigrade. Using the figure 4.1, determine the increase in the energy in the internal energy store of the wax between t equals to 0 and t equals to 220 seconds. Show your working. Okay. So we have to look at that 220 seconds. So I have to first of all find out that 220 seconds. What is the okay, 220 seconds is this one. This is 220 seconds. So that means here. Okay. So that means this. This is how much? 41, 42, 43, 44. I think 44 is the temperature. So, okay, not 44, it's 48. Oh, yeah. This is 42, 44, 46, 48. Okay. And here you have 50. Sorry, sorry, sorry. So this is 50. So this temperature is, I thought 44. It's 48. Because this is 16. So 48. Sorry for that. Okay. So I know the initial temperature. So you can say that the theta 1 is 21. Theta 2 is 48. The change in the theta is 48 minus 21. And the formula for the heat is equal to the mT delta theta. So m is the mass which is given here. The mass is m. Here T is the specific heat capacity which is given here. And you see, and the delta theta is this one. Okay. So just put those values here and you will be able to calculate that heat. So heat is equal to mc delta theta. So here we have that, and 0.040 multiplied 2100 multiplied 27, and this is 2268 joules, which is approximately 2300 joules. 2300 joule is the right answer, sir. The marking scheme is showing up on your screen. So this is how you do this question, and I hope you understand this. Okay, so let's go to the next part. Okay. So here we have, describe what happens to the motion of the molecules of the solid wax as the internal energy of the wax increases. You see, when the internal energy of the wax increases, basically what happens, the kinetic energy increases of the particles in that wax. And what happens, they start moving faster. Their motion, basically they are their motion is actually their motion is basically vibration. Okay, so they are basically vibration becomes vigorous, and the amplitude of their vibration will increase. Okay, their vibration will become vigorous, and the amplitude of their vibrations will increase. As when the temperature increases, the kinetic energy of the particles of the wax also increases, so they start vibrating more vigorously. The amplitude of their vibration increases. Okay, so this is the gain in the kinetic energy, move faster, vibrate more vigorously. Remember this word, more vigorously, and you can say move, vibrate more faster. So this is my answer, sir. And here we go. So now we have the C part of the question number 4. When the wax reaches its melting temperature, the energy continues to be transferred thermally to the wax. Describe in terms of the forces between particles why energy is required to melt the wax. Okay. when you reach the melting point. Okay, so at the melting point, the heat you provide, you are providing the heat, but the temperature provide the temperature do not rise. Okay, the kinetic energy do not change. Okay, so you are providing heat, the thing is melting, but the temperature remains constant. This is very important for the state thing. The temperature do not change. So where this heat is going? So this heat is basically going to the heat you provide is used to overcome the intermolecular forces. It is being used to intermolecular forces to move particles away. This heat is called the latent heat. This heat is called the latent heat. So this is basically happening during the melting process. The heat you provide, that heat is called the latent heat, and that heat is used to overcome the intermolecular forces, and that heat is used to overcome the forces of attraction between the particles, and that heat is used to move the particles away from each other. Let me show you my written answer, sir. That was my explanation for you, and here we go. During the melting, the heat provided is used as latent heat. This heat is used to overcome the intermolecular forces and move the particles of the wax away from each other. It's a 2 marks question, sir. So he says work is done on the molecules or latent heat supply. The forces between the molecules overcome molecules separated against attractive forces or break bonds. Okay, so this is my written answer. You can always write a better answer, sir. This is just an this just we provide you only a suggestion that you can write the answer like this. Okay, so now we are on the question number 5. He says the microwave region is one region of the electromagnetic spectrum. Figure 5.1 represents the electromagnetic spectrum divided into 7 parts. So you remember that code word which we use to remember these electromagnetic waves. Ronald McDonald is very ugly except Gary. Okay. So radio waves, microwaves, infrared, visible light, ultraviolet, X-rays, and gamma rays. Okay. So as you go down in this, so what happens? The wavelength decreases, frequency increases. Here, the figure 5.1 represents the electromagnetic spectrum divided into 7 main regions. These regions are arranged from left to right in order of increasing wavelength. On the figure 5.1, indicate the microwave region by marking it with the letter M. So the radio waves, the microwaves will be here, and then we will have infrared. Here you will have infrared, then you will have the visible light, then you will have the ultraviolet, and then you will have the X-ray. So they ask us to write this and this. It's a 1 mark question. Let me show you. I have also done this. Okay, so here we go. So it's a 1 mark question. So I hope you understand this. Let me show you the marking scheme of the question number 5. Here we have the marking scheme of the question number 5, A part. Okay. Then we are going to the next part, B part. He says the frequency of the microwave used in some satellite television systems is 12 gigahertz. The speed of the microwave in the vacuum is 3 × 8 meter per second. Calculate the wavelength. Okay, you know the V is equals to F lambda. So if you want to find the lambda, that will be V divided by F. Just put these values here. But this frequency, this is 12 gigahertz in this formula. The frequency must be in the hertz. So giga means into 10 raised to power 9 hertz. So use this value and this value because this is the speed. You will be able to find out the wavelength. Let me show you my answer, sir. Okay. So here we have. Okay. So convert the frequency into the hertz, and this is the speed. V is equal to f lambda. So the lambda will be equals to 3 expo 8 divided by the 12 expo 9. When you do this on your calculator, you will get 0.025 meter. Let me show you the answer, sir. And this is the answer. I hope you understand it. Okay. So the question number 5B and its second portion is a 2 mark question. Describe how the microwaves are used in the satellite television system. You see, on Earth, we have the television station. And let's say this is your television station. This is your television station. So in the space here somewhere you have that satellite. So what happens is send the signal microwave in the form of microwave to that satellite in the space, and that satellite receives that signal and it amplifies it. On the earth somewhere you have a dish antenna, and this dish antenna is connected with a television. Okay. So what happens? The satellite sends the signal to the dish antenna, and the dish antenna through the decoder send the signals to the television, and you are able to see the the transmission. So these are the microwaves. The signals sent and received back, they are in the form of the microwaves. Microwaves are very good for this satellite television uh, uh, transmissions because they are not absorbed or stopped by the atmosphere. So here we go. From television station on Earth, signal in the form of microwaves are sent to satellite in space. Satellite amplifies signal and sends signals in the form of microwaves to Earth. On Earth, dish antennas are used to receive the signal, and with the help of a decoder, transmission can be seen on the televisions. This is my answer, sir. And here we go. You can see the question number 5. It's B, second part. Encoded microwave signals, microwaves carrying data, microwave transmitting data to satellite from Earth. Satellite transmits microwaves to Earth, dish antenna, subscriber, television. Okay, so this is their answer, sir. This is the answer written by me, and this is my explanation. Okay, here we go. Question number 5 and its C part. He says all microwave ovens have a switch that turns the oven from off when the door is open. So that's why it is important for a microwave oven to switch off when the door is open. You see, the if 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 the door is open and the microwaves are still being produced in the microwave oven. So any person which is standing near the microwave, his hands or his face will receive those microwaves. And those microwaves, they can increase the temperature of the cells, the tissue, the skin, and the skin will get burned, and it is very harmful. You will get, it's like your skin got burnt, and you will have blisters, you will have like something got burnt. When door of the microwave is open, and if it is still producing microwave, these microwaves can escape from the microwave oven and uh, and cause burn to anyone close to the microwave. Okay, he said to prevent microwaves escaping, leaving the oven, spreading out of the device. Microwaves, they can cause burns in the living tissue, people, damage to tissue through heating and blisters. Okay, so this is how you will do the question number 5. It's C part. I hope you can write a better phrase. You can phrase these answers in a better way. Let's go to the next question. The next question coming up on your screen is the question number 6. And he says an electric car is driven by a direct current, DC current. Motor that is powered by a direct current power supply. Describe how a DC current differs from an AC current. You see, the graph for the DC current, AC current, the graph for the DC current, if here is the voltage, here is the time, the graph is always a straight line. But in the case of the alternating current, the graph shape is something like this, okay? It goes up, it comes down, it goes up, it comes down, it goes up, okay? So you see the direction of the AC current changes is reversed. Its magnitude is also magnitude changes. Okay. But here the direction constant, it do not change. And the magnitude is also on. I'm just trying to explain to you. It's a 1 mark question, okay? So in the case of the alternating current, the direction and the magnitude of the alternating current is periodically changing. And in the case of the DC current, the direction do not change, the magnitude even remains constant. Okay, so here we have that my answer is coming up. DC has only one direction, whereas alternating current direction reverses periodically. Okay, so question number 6, its A part is showing up on your screen. Okay, this is my answer, sir. Now, figure, he says 6.1 represents the motor circuit. Point P is a point in the circuit between the motor and the positive terminal of the power supply. Point P is shown to the left of the motor in the circuit diagram. During a time of 120 seconds, the current in the circuit at the point A is 41 ampere. Calculate the charge that flows through the point P in the time of 120 seconds. So it's a very simple question, you know that I is equals to the charge divided by the time. So the charge will be equal to the I multiply T. I means the amount of the current and T means the time. So here the amount of the current is 41 ampere and the time is 120 seconds. You can calculate very easily the amount of the charge here. So I is equals to Q by T. The Q is equal to the I multiply T. Q will be equals to 41 multiply 120. So that's 4920. So it's like 4.9 x per 3 coulomb. So 4.9 x per 3 coulomb. This is our answer, sir, and that answer is right. Okay. So this is the answer first. Okay. Next question number 6, and its next part is the current in the circuit is due to the flow of the electrons. Each electron carries a charge of magnitude of the charge on one electron is this much. State the direction which the electrons move past the point P and determine. So they are talking about electrons, determine the number of electrons that pass that point P. So the electrons, we are not now talking about the conventional current, we are talking about the electrons. The electrons will be always going from the negative terminal of the battery towards the positive terminal. So the electrons are going in this way. The electrons are going in this way. We are not talking about the conventional. We are talking about the electron flow. The electron flow at the point P is going from the negative terminal of the battery towards the positive terminal of the battery. So this will be the direction, and then their question is how many electrons will how many electrons pass in 1 second. This is a tricky thing. 1 second they are saying. You see, I know that in the amount of the charge in 120 seconds, we just calculated that 4.9 x per 3 coulomb. So in 1 second, how much charge will flow from there? So that will be because this 4920 amount of charge flowed there in 120 seconds. So in 1 second, the amount of the charge will be equals to 41 coulomb. So number of electrons, the amount of charge divided by the charge on one electron, 41 divided by 1.6 x 4 minus 19. Just do this calculation on your calculator. You will get 2.6 x 4 20. So this much electrons are flowing there in 1 second. Okay, 1 second, 2.6 x 4 20, and the answer is okay. Here we have the answer. This is how this is done. I hope you understand. And we are going to the C part of the question number 6. He says the power supply for the electric car is a number of batteries, each made from a large number of identical cells. So they are identical cells and they make up batteries. The EMF electromotive force of the each cell is 3.5 volt. Define the term electromotive force. Electromotive force is the work done by the battery or by the cell to move unit charge in a closed circuit. So let me show you my written definition. It's a very famous definition. It says the amount of the work done by the cell to move unit charge in closed circuit is called the EMF of the cell. So here we go. The definition of the EMF is given here. So let me go to the next part, sir. C and its second part, he says each battery consists of 92 cells. Calculate the EMF of the battery connected in the series. So the EMF will be equals to, because there are 92 cells, each cell has 3.7 volt. Each cell has 3.7 volts. So just multiply them, you will get the answer, sir. 92 multiplied 3.7, that will be 340.4. So approximately 3 volt, 340 volt is the answer. So the EMF of the battery will be 340 volt. Okay. Then they say that, then we have another question. He says the power supply is made by connecting 85 of these batteries in parallel. So if you connect the batteries in parallel, and they are identical batteries, I'm just trying to explain to you. If you connect them in parallel like this, I just connected three batteries. So each battery is of 340 volt, and if you have connected 85 of the batteries, they will all have this. The combination, the whole combination, uh, the EMF of this whole combination, will be equals to the EMF of an individual battery. So it will be also 340 volt. It's a conceptual thing. So I hope you understand this. Question number 6. So now we have the question number 7 coming up on your screen. He says an electric kettle has an outer casing made of metal. Figure 7.1 shows the kettle. So here we have the main supply, cable, electric kettle, metal outer casing. The heater in the electric kettle is connected to a 3 volt main power supply and has a power of 2, this is the electric power, 2300 watt. Their question is A part, question number 7, A part. The kettle is switched on. Calculate the current in the heater. You know the power is equals to the I. V. I means the current, V means the voltage, the P means the power. And very easily you can calculate the I, that is P divided by V. Just put the values, you will be able to calculate it. So here we have that answer. So P is equals to IV. So I will be equals to P divided by V. So 2300 divided by 230. So that is 10. So what will happen? The current is 10 ampere. Okay. So let's check the marking scheme, sir. So the answer is question number 7. The answer is showing up on your screen. It's 10 ampere. Okay. So let's do the next one. Question number 7. It's A and it's second part. Okay. So this answer is 10 ampere. He says the manufacturer of the kettle states that the cable for the kettle is safe for the currents that are smaller than 15 ampere. It means that that cable which has been connected with the electric kettle that can only bear up to 15 ampere. Any current which will be more than 15 ampere will melt this cable. The wiring in the main supply in the wall is safe for the currents that are smaller than 20 ampere. The wiring which is done in the home or in the inside the wall that can only handle a current of 20 ampere. If that exceeds the 20 ampere, the wiring in the wall will melt. The fuse available for the kettle have the rating shown. State which of these fuses is the most appropriate. Explain why it is the most appropriate. Okay, the most appropriate because your kettle is going to take 10 amperes, so I'm going to choose this. So no, don't use this. Because the current is 10 amperes, so you cannot use this. We will use a little higher. Okay, so I think 13 ampere fuse, the fuse which has 13 amperes, that will be the best fuse. Okay. Then now I have to explain why I'm not taking, why I took 13 ampere, why not anything less than 13 ampere. You see, all, all of these, all these, which are less than 13 ampere, you cannot use them. Why you cannot use them? Because your kettle will take 10 amperes. So if you put a fuse like 3 ampere, 5 ampere, 7 ampere, or 10 ampere, your kettle will normally take 10 amperes. We just calculated that. So if you put a fuse which is of 10 ampere or less than 10 ampere, that fuse will immediately blow. It will melt and your kettle will not work because your kettle normally requires 10 ampere. We just calculated that. Okay. Now, if I choose um, and anything, a fuse rating more than 13 ampere like these ones. So the first allegation we have is on this number, 15 ampere. You see, your wiring can only handle the cable which you have connected with the kettle. That can only handle the current less than 15 ampere. So if that wire is melting, this fuse will not, uh, you know, this fuse will not blow. And if your kettle only takes 10 ampere, there's something wrong in the kettle. So let's say it is taking 12 amperes. So this fuse will not melt. Or this, you see? And this is not right because your cable will be melting, the fuse will not melt. This is not good. This is also not good because your kettle will be short circuited, but this fuse will not blow the 25 ampere. So these fuses, you cannot use them. These fuses, you cannot use them. The only good fuse is this one. I don't know, but let me show you the written answer which I wrote. If we use the fuse rating less than 13 ampere, fuse will blow, melt because the current needed for appliance is 10 ampere. Your appliance need 10 ampere current. We just calculated. If we use the fuse rating greater than 13 ampere, it is not safe for cable, for the kettle, because cable can only bear less than 15 ampere current. So I try to write this, but I hope you can write a better answer, sir. Large current in the earth live wire. Sorry, where is that? Yeah, here we have. He says does not blow when the kettle is used in larger than the current in the kettle operating current and protects the cable. Wiring in the wall power supply is slightly larger than the current in the kettle. So this is their answer. And this is the answer which I wrote. I hope you can write a better answer. So let's go to the next part. So question number 7, and it's a B part. He says there are three wires in the cable that connects the cattle to the main power supply: the earth wire, the live wire, the neutral wire. The wires are commonly the wires are all correctly connected. So they are correctly connected. Okay. Say the name of the wire that the fuse is connected into. Explain why the fuse is connected in this live wire. You see, we always connect the fuses in the live wire. And why we connect in the live wire? So that when the fuse blows due to the surge of the current, and the when the fuse blows, if it's connected in the live wire, it will disconnect, it will isolate your appliance from the high voltage live current, and the appliance will become safe for repairing. Okay. So here we have, I have written if the live wire, and if the fuse blows or melt, appliance will be isolated from live high voltage current coming from the supply. Okay, this is my answer, sir. And he says, you can see the B first part. Okay. Then we have the question number 7, B part, second portion. He says the insulation on the live wire is damaged so that the wire is exposed. Express what happens when the exposed wire touches the metal outer casing. You see, when the live wire will has damaged insulation on it and it comes in contact with the casing of the cattle, the current will start going, the live current, high voltage current will start going into the casing. And from the casing, it will go into the ground. If somebody will touch the casing of that cattle, he will be or she will be electrocuted. Now see what happens when the current is going into the ground. The current coming from the live wire from the main supply, that increases because the current is going to the electric cattle plus the current is going through the body and through the earth wire into the ground. So the current coming from the main supply will increase. So the fuse will melt, and when the fuse will melt, it will cut off the supply of the live current to the cattle, and the cattle will become safe for repairing and for touch. Outer casing will also become live through casing. Current will start going into the earth wire. Current coming from supply will increase. Fuse in the main live wire will melt. Okay. And what will happen? Fuse will blow and the current, so this is the answer given here. Question number 7, B part, its second portion, the marking scheme is showing up. This is the answer which I try to wrote. And here we go. Question number 7, and it's C part. He says the cattle is switched on for a total time of 34 hours during 1 year. So this is the time in hours. The time is given. And he says the cost of the electricity is 0.32 kilowatt hour. Okay. Calculate the cost of using the cattle during this. The power, the electric energy is equal to the power multiplied time. This must be taken in the kilowatts, and the time must be taken in hours. Once you know the unit of the electric energy is kilowatt hour. Okay. So here we have electric energy is equal to the power multiplied time. The power of the electric kettle is 2300 watts. We will divide it with 1000 to convert this into the kilowatts. And the time for which the electric kettle is used in 1 year is 34 hours. Just multiply them, you get 78 kilowatt hour. Now the cost of the electricity is the units which we have used, multiply the price of the 1 unit. The unit means that the unit means 1 kilowatt hour. So it's 78 kilowatt hour, and the price of the 1 kilowatt hour is $0.32. So just multiply them, you get 25.02. So the cost will be 25.20. The bill will be 25.20. So this is the answer, sir. Our answer is right, sir. So let's go to the next question. The next question coming up on your screen is the question number 8. He says the element lithium uh, has several different isotopes. State one way in which the composition of the atom of the lithium isotopes are the same. Okay, we have to cut. So all the atoms of an isotope, they all have the same number of protons in their nucleus. So the same thing in them is the number of the protons in their nucleus. Okay. So let me show you. Oh, here we go. My answer is there. Okay. All the isotope atoms have the same number of the protons in their nuclei. Okay, so this is the question number 8 coming up on your screen. Okay, number of protons will be same. Then the question is state one way in which the composition of the lithium atom of one isotope is different from the composition of lithium atom of the different isotope. So the number of neutrons are different. In them, the number of neutrons are different. On that, on because of they have the same number of protons, but the number of neutrons in their nucleus is different. So due to that, what happens? They have the different number of the nucleon number. Their nucleon number will be different. They have different number of neutrons in their nuclei. They have different nucleon numbers. Their mass number is different. Okay. So I hope you understand this. Okay. So then we have the next question. He says, um, if you look at this, the figure 8.1 is the B part of question number 8. Figure 8.1 is a diagram that represents a neutral atom of a radioactive isotope of lithium. So there are electrons, and how many electrons are there? There are 3 electrons. How many protons are there? It's a neutral atom. There are 3. How many neutrons are there? There are 2 neutrons. Okay. He says there are 3 electrons in the orbit around the nucleus. The nuclide symbol for the isotope lithium are represented by lithium XY, where X and Y are the numbers. Determine the number X and the number Y for the isotope represented here. The up here here on the top you write the mass number. Here you write the proton number. Mass number is also called the nucleon number. The nucleon number is the sum of the protons and the neutrons, so that is 5. And the proton number represents the number of protons, so this is 3. So let me show you, this is the answer which I have written. Okay, and I can also show you the marking scheme. Okay, so this is our answer. Okay, then he says an isotope, an ion of an isotope, lithium has a single positive charge and is represented by this. Describe how the diagram that represents this one is different from the it. So when lithium will become a positive charge, it would have lost 1 electron. It would have lost 1 electron, that's why. Lithium positive will have 2 electrons in its shell around the nucleus. This neutral lithium has 3 electrons in its orbits, but in the case of the lithium positive one, it will have, 1 electron. It will have only 2 electrons. It has given away 1 electron. Okay, so let me show you the marking scheme. Okay, so then the question is question number 8 and beta, it's C part. He says a radioactive isotope emits nuclear radiation which can affect the living things. State one damaging effect of the nuclear radiation. You say it can cause the skin burn, it can cause mutation of the cells, it can cause cancer. That's a straightforward question. So, exposure to the nuclear radiation can cause cancer. Just have to write one. So these are all given. Hair loss is also So you can write one of them, okay? So then he says the emission of the radioactive radiation from an unstable isotope is described as the random and spontaneous. What is the meaning of the random and what is the meaning of the spontaneous? Okay. Random means that you cannot predict that at what time uh, decay will happen. And you can also not predict that which atom will decay. This is the meaning of the random, that you cannot predict the time, you cannot predict that which atom will decay. Spontaneous means that once this system starts, once that unstable nucleus starts decaying, it does not need any external temperature, any external heating. It does not require anything externally. This happens spontaneous on its own. Okay. So, the meaning of the random, it is impossible to predict which particular nucleus will decay or when it will decay. This is the meaning of random. You cannot predict it. And spontaneous means that the decay happens by itself without any external influence, such as temperature, pressure, or chemical change. Spontaneous and random. Okay, so here we have this. You can read this. Okay. It means emission is unpredictable in time, direction, or any fixed time interval between decays, or emission follows no pattern or no fixed values, or emission rate varies, differs in the time. And then we have spontaneous emission not influenced by any external factors, temperature, pressure, chemical combination. No trigger cannot be controlled, happens on its own, just happens. Let's check. So we are done with the question number 8. Now we are on the question number 9. He says in the figure 9.1 shows how the sun and the rest of the, let me increase the size. This is figure 9.1. He says the figure 9.1 shows how the sun and the rest of the solar system orbits around the center of the Milky Way in a circular path. Okay, so this is Milky Way basically, and our sun is here and it's orbiting in a circular path. So what's the question? The sun travels around a circular path at a speed of v. The speed of the light in a vacuum is 9.5x per 12 kilometer per year. Okay. The sun is 26,000 light years from the center of the Milky Way. Their question is determine the distance from the sun to the center of the Milky Way. So their question is basically find the distance between the sun and the center of the Milky Way. So it takes 26,000 light years, and the speed of the light is also given in kilometers per year, and we know the years. So very easily we can find the distance. So it's 9.5 into 10 raised to power 12 multiplied 26,000. So it will be 2.47 expo 17. So that's 2.5 expo 17 kilometers. Very simple, straightforward question. Question number 9. So the answer is right, sir. So 505422 paper. This is October November 2025, Cambridge O levels physics. So we are done with this question, part A, I mean, its first portion. Then he says takes sun 2.3 expo 8 years to complete one orbit around the center of the Milky Way. Calculate the V, and the V here is in meter per second. So the V is equals to 2 pi r divided by T, and this must be taken in the meters. Okay. So this is the formula for the orbital speed. Speed is equal to 2 pi r divided by t. So 2 multiply pi multiply the radius of that orbit is 2.5 x power 17 kilometer. And then I multiplied it with 1000 to convert the kilometer into meter. And it says 2.3 into 10 is power 8 years. So I multiplied it with the 365, then multiply with 24, multiply with 60, multiply with 60, because I'm converting those years into seconds. So you will get 2.1 expo 5 meter per second. 2.1 expo 5 meter per second is the right answer, sir. I hope you understand. The formula for the orbital speed is circumference divided by the time and 2 pi r divided by time. Because he asked us to find that speed in meter per second, that's why we converted the radius into the meters from kilometers and the time from years into seconds. So I hope you understand this. Okay. Then he says an astronomical observation suggests that at the center of the Milky Way there is a black hole. Okay. And black holes are produced from the red supergiant. Near the end of its life, a massive star becomes a red supergiant. Describe what happens inside the star as it becomes a red supergiant. You see what happens the in the core of that star, most of its fuel has burnt out. So what happens due to that? The core becomes the fusion of that helium, hydrogen to helium stops. So under the immense pressure, that core contracts. But in the outer layers, and when that core contracts under the gravity, what happens? The temperature rises, and that starts the fusion of the hydrogen in its outer layers, which is covering the core, and due to that, it expands. You see, let me show you the written answer. He says that most of the hydrogen in the core has been converted into helium. The core contracts and becomes hotter. Hydrogen fusion continues in a shell surrounding the core. Increased radiation pressure causes the outer layers of the star to expand, and we call it superjoint. Let me show you the marking scheme. It's very important. Okay, so you should know this. Most of the hydrogen has been converted to the helium. It runs out of the hydrogen fuel. Outer regions expand. Radiation pushes the surface of the solar star outward. Center of the star core contracts to center of the star core becomes hotter. The hydrogen surrounding center of the star core begins to fuse, burn. Radiation pressure increases. So this is my written answer. This is the answer written there. You can always write a better answer, sir. So the second part is describe how a red supergiant produces a black hole. Okay. So what will happen? The fusion reaction stops in the core when the nuclear fuel is exhausted. Radiation pressure decreases and the gravity causes the core to collapse. The core collapses to an extremely small, dense object, forming a black hole. So in the marking scheme, it says the red super giant it explodes the supernova and then producing a nebula leaving behind a black hole. This is the answer written by me, and I have not mentioned here supernova. You can also mention a supernova here. Okay. So then he says, describe how the heaviest elements are produced. You see, when the supernova happens, in that supernova, the, the the larger elements fuse into each other, and they produce even a larger elements. Okay, like hydrogen fuse with each other, they make helium. So hydrogen is a smaller element, or you can say, and they create a heavier element. So further, helium will fuse with each other and they will make new elements which will be very heavy. This happens during the supernova explosion. During supernova explosion, smaller nuclei fuse with each other to form larger nuclei, and in the case of the supernova, they spread out and in the space. In the supernova explosion, lighter nuclear elements join forces to gather small nuclei fuse. Okay, so this is the answer, sir. Um, for these two answers, I will suggest you can also check your books and these answers, and you can also write better details. Okay, and you can consult your marking scheme, your teacher as well. I have also tried to write the answers, sir. You can ask your AI also to write the answers for you, and you can consult different people for these answers. So we are done with this paper, I think, and we have reached the end of this paper. Okay. So, my dear students, thank you all for watching this video and using this video to do this paper. And if you think that this video is helpful, if you think this video can be helpful to your class fellows or your cousins or your teachers or your junior students, please share the link of this video with them. Share the link of this video on WhatsApp groups, in Google Classroom, in your Facebook, on your TikTok, on your Instagram, and like this video. Also subscribe my channel. You see, when you subscribe my channel, when you like my video, when you comment on it, when you download these videos, when you share these videos with your those students who need this, the O-level students and IGCSE students who need these videos. This is a great support and appreciation for my work. Your support and your appreciation, they both are very, very important for me. So thank you very much, everyone. Have a good day. God bless you all.